Hey guys, this is a PowerPoint that I wanted to make for you guys for balancing equations. It's not supposed to be difficult whatsoever. So let's just take a look at this first video, which is going to give you the introduction to equations and what they look like. So some of you have a good grasp of it already. Some of you guys don't. So we're just going to start over from scratch. All right, so let's take a look at this PowerPoint. I'm going to put it on the classroom page for you guys to open it. And we're just going to cover these specific slides and only these. Then I'm going to have another presentation with just balancing equations on them. Okay. So what are chemical equations? Is a representation of a chemical reaction. That's the written form. It's like the recipe. It's the numbers and the elements that are present during a chemical change. Okay, very simple. It's what's in a beaker, what's in a test tube, written down on paper. Now, in a balanced equation or a chemical equation, there's going to be the reactants on the left side and products on the right side. Okay, there's going to be symbols that go along with the reactants and symbols that go along with the specific products. Okay, now what is the purpose of the chemical equation? Well, later on, we're going to use a balanced equation to determine something called molar amounts. That's just a term you need to know for the future. Okay, like 1 dozen is 12 eggs. We're going to have 1 mole of a specific substance, or 2 moles, or 3 moles, or 4 moles. It's like 1 dozen, 2 dozen, 3 dozen. You guys all know 3 dozen is 36 eggs. It's very similar. Okay, so balanced equations are an important step in order to create a specific equation. Now, there's something called a skeleton equation. It's basically an unbalanced equation. Okay, like this right here, we have H2 plus O2. That's hydrogen gas plus oxygen gas, and the two of them come together to form water. Now, to balance the equation, we use this term called coefficients. Coefficients are the numbers that are placed on the blank lines in front of the compounds. You cannot put a number in between a compound or behind a compound or above. They can only go in front. If you put it somewhere else besides in front, you will be doing it wrong. It's not the correct distributive properties of math that you've learned over the course of your high school career. Okay, so coefficients are only placed in front and will always only be placed in the front. Okay, so that coefficient gets multiplied through the compound, like this 2 here will multiply to the H, creating 4 H's. There's technically a 1 right here. In chemistry, we do not have to write 1, so there's 2 oxygens. There's a 2 here in front of the H2, which makes 4 H's on the right and 2 O's on the right. So therefore, it is now a balanced equation. You have 4 H's on the left, 4 H's on the right, 2 O's on the left, 2 O's on the right. Simple. We're going to continue more of this. Just an example. Okay. So this tells us, importantly, right here, the law of conservation of mass is satisfied. You have the left side and the right side equal amounts of the number of elements present. Okay? You have 4 H's, so there's 4 grams of hydrogen on the left, 4 grams of hydrogen on the right. It's like a scale. You have to balance it. Okay? You have 2 oxygens on the left, that's 32 grams, and 2 oxygens on the right, that's 32 grams. So the mass is conserved. It is the same. It's like taking a Lego house. You build a Lego house, 200 pieces. You weigh it. Turns out to be 200 grams. You smash it up. It's still going to be 200 grams. All those Legos put together make up the mass of the house. Okay. Now, there's some symbols used in chemical equation. I'm going to go through them kind of quick because you can just refer to the slide again. Okay. So we have plus, which is written in equations, which means it's going to separate 2 elements or 2 compounds. An arrow to the right means yields or produces, you can call it. And then you have a double arrow, one going right, one going left. That's a reversible reaction. So a reaction can go one way or it can go the other way. SLG in parentheses specifically and only states solid, liquid, and gas. Okay, when it's in parentheses, not grams or liters or seconds. Okay, when it's in parentheses, you must understand that. So note, in parentheses, SLG is solid, liquid, or gas. All right. Sometimes the L could be written in a little cursive L. So as long as it's in parentheses, it's a solid, liquid, or gas. And this will be usually written after the element or compound that you're working with. Now, AQ is a very interesting thing. A lot of kids don't understand this, but it's very simple. Aqueous solution is where you're taking a substance, like a solid, and mixing it with a solution, okay, or water. So basically like a packet of iced tea, you rip it open, you pour it into water, you're making an aqueous solution. Okay, so salt dissolved in water would be an aqueous solution. Okay, so salt plus water. So like a mixture. Okay, notice it says aqueous solution. Solution is a homogeneous mixture. We learned that already. This is my favorite one. Arrow to the right with a triangle on top. Triangle on top just means that you're going to heat it up. Doesn't specify what temperature. Okay, you're just going to like test tube above the Bunsen burner. You're heating it up gently. You're not going to burn it. You're not going to warm it. You're heating it. Okay. Now, in college, you're going to learn that when there's a number above the arrow, degrees Celsius or kelvins, you're going to heat it up to that specific number. It could also be cooled. But in this case, in this class, we usually primarily use heat and heat only. All right. And then another one of my favorites is an arrow to the right with a compound written above it. This indicates a catalyst. So this MnO2, this is called manganese dioxide. Okay, we didn't do naming yet. So MnO2 is going to be used to speed up the reaction, make the reaction occur faster. Okay, some reactions will take hours to complete, but the second you add a catalyst to it, it lowers the energy of activation and makes the reaction go a lot faster. Okay, this is actually manganese 4 oxide. Okay, you uncrisscross these. Now, a couple clues that a chemical reaction occurred, all right, are as such. Number one, there's some form of heat and light. A hot pack, okay, a flame of some sort. There is heat. There is a converting of matter into a new type of matter, and energy is given off. Like the magnesium that I gave you during lab, you put that in the Bunsen burner, then the magnesium lit and burned bright. Okay. Production of a gas. This is where you looked in a test tube in the past and you saw little bubbles being formed. Well, the bubbles is not air. It's actually oxygen or some other gas coming out of the bonded compound it was originally attached to, forming a gas. Okay. So sometimes they're very small bubbles, sometimes there's a lot of bubbles, depending upon the reaction. So you have to really be careful and judge. You might have to use a magnifying glass to look in there, especially if it's in a test tube and it's a low, weak reaction. Another one is formation of a precipitate. We can identify it as a PPT, letter P, letter P, letter T, instead of writing precipitate all the time. Think of precipitation, rain, snow, sleet, hail. It comes from the sky. So when you mix two chemicals up, the two chemicals can create a solid, which looks like snow in a test tube. There are some precipitates that look murky or cloudy that are precipitates, yes. They're not nice looking, but yes, they are new compounds that form. So that is a very important visual aspect to indicating if a chemical reaction occurs. Precipitate is a big one. A lot of medicines come from precipitates, believe it or not. Okay. Color change. Okay. You can have many different colors change. For example, fading. You can have a black piece of paper sit for 10 years and then black piece of paper turns brown. Why? Well, the dye, the chemical dye inside that makes the black color begins to break down or fade, creating a brown color. Okay, in my classroom, I have evidence of that. And you can see that around other places. Also, when you mix up two chemicals, you can have two clear solutions mix up and then all of a sudden turn brown. Or two clear solutions, you mix them up and they turn yellow. Okay? So what is happening? What is the color change? Color change is how light is being bent through the molecule. So think of like a piece of glass, and that glass reflects light into a certain color. If the glass gets bent, heated, twisted, or breaks, it's going to reflect light differently. And that's what happens. The molecule then begins to twist, bend, or alter somehow, some way. We just have to imagine it. And then the light goes through it, bending the light in a different angle, causing a different color to be seen. Okay, that's what a real color change is, based on the composition of the substance. Okay, it's actually very, very simple. And then now what we're going to do is I'm going to stop this video and then I'm going to create another one based on balancing a few equations. Okay, just to review all of this good stuff.